Hi, everybody. We are going to give just a couple more minutes in case any more attendees do log on. While you're waiting, feel free to take a stab at today's trivia question. Put your answer in the chat and we will answer that before we get started. I'm just going to give it one more minute to see if anybody else joins us. For those of you that have joined within the last few seconds, we do have a trivia question for you guys to try to answer. Just put your answer in the chat and we will cover that before we begin the webinar. All right, so I think we are going to go ahead and get started. We have a lot of material to cover today, so I don't want to hold this up too much longer. So welcome to the Pollution Prevention Discover Green Sustainable Pathway Technologies webinar. My name is Jen Jones, and I will be your host, and I'm being joined today by Dr. Robert Voigt from Penn State University. Before we begin, let's answer today's trivia question. So what is the EPA's most preferred method to reduce waste under the waste management hierarchy? And if you answered C, you are correct. Under the EPA's waste management hierarchy, source reduction and reuse is the most preferred method, while treatment and disposal are the least preferred. Energy recovery is the second least preferred, and recycling and composting is the second most preferred method. So let's get started. Speaking of this webinar, we are being sponsored by the United States Environmental Protection Agency, and this webinar is being held as part of National Pollution Prevention Week. That is actually this week. So for more information about pollution prevention, you can use the QR code here on the slide, and it'll take you to their website where there is a wealth of information available about pollution prevention measures for both your business and your home. Before we begin, I have just a few quick items of business to cover. If you have any technical difficulties accessing or hearing the presentation, please use the chat and we'll try to correct them promptly. This presentation will last approximately 40 to 50 minutes, followed by a question and answer period. We are going to wait to answer any specific questions until that time to allow us to move through the material efficiently. If you have questions after the webinar is over, please send them to us via email at pentap@psu.edu. We are recording this webinar and it will be uploaded to Pentap's website at a later date, and you will receive a follow-up email notifying you when that is available. So as I said, we're very excited to have our guest speaker today, Dr. Robert Voigt. He is a professor of industrial and manufacturing engineering at Penn State University. He received his PhD in metallurgic engineering from the University of Wisconsin in 1981. My name is Jen Jones. I am the North Central Regional Advisor here at Pentap. I am a certified energy manager, a certified Six Sigma Green Belt, and a certified water efficiency professional. I also hold a bachelor's in wildlife biology from Penn State University, and prior to coming to Pentap, spent about 10 years in environmental consulting. So during today's webinar, we will briefly discuss Pentap services. I will then turn it over to Dr. Voigt, who will discuss green sustainable pathway technologies. And as mentioned, we will close with a question and answer session. So who is Pentap? We are a statewide technical assistance organization charged with supporting Pennsylvania businesses and anchor institutions, which include manufacturers, educational institutions, entrepreneurs, and economic development agencies. We began well over 50 years ago as one of the first technical assistance programs in the country. We complete energy efficiency and pollution prevention assessments for manufacturers and small businesses throughout the state of Pennsylvania. Our E3 assessments combine energy efficiency and pollution prevention with the principles of continuous improvement. And we also assist a small cohort of clients to become ISO 50001 ready. Our innovation services assist clients with product and process development and connect them to the myriad of resources available through Penn State and our network of statewide resource partners. I am proud to say that the work we do at Pentap aligns with 9 of the 17 UN sustainability goals. At our core, our services serve to support industry, innovation, and infrastructure. Pentap does this by educating Pennsylvania manufacturers and Penn State students on energy efficiency and pollution prevention measures, which leads to clean water and helps to keep energy affordable. Our innovation and energy services allow for economic growth and ensure the communities our clients serve can thrive in a sustainable manner. We promote responsible consumption and production at the facilities we visit, which reduces their carbon footprint, and connecting clients to our network of statewide resource partners ensure that they have the support needed to continue to grow in a sustainable manner. In 2022, we helped Pennsylvania small businesses achieve $11.4 million in economic benefits across 40 counties within Pennsylvania. We educated over 1,000 individuals and saved or created 85 jobs. I will now turn it over to Dr. Voigt, who will discuss the green pathway technologies for pollution prevention.
Thank you, Jen. I hope that everyone can hear me. You're not going to be able to see me, so I may be in my pajamas, I may not, but it doesn't really matter. But it's a pleasure to join all of you via Zoom and talk a little bit about green sustainable pathway technologies. That's a mouthful, but I want to talk about something that can impact your organization. I'm going to spend just a moment talking a little bit about myself to introduce me to you. I want to introduce the industry that on which most of the case studies have been based, and that's the metal casting industry. And then we're going to talk through some practical examples of pathways for success in the green sustainable world for small and medium manufacturers. If you look at that graphic on the left-hand side, you know that if you ask the general public, they support green. But their image of manufacturers is typically different than that. They look at them as people that are in business to make money. And if they pollute, that's that's acceptable to industry. But we all know this is not the reality. We all know that as manufacturers, we have a very important role in keeping our planet green, and we have to find pathways so that we can become more sustainable, reduce emissions, reduce solid wastes, and at the same way, do that in a pathway that keeps us financially stable. And that's what we're going to talk about this morning when it comes to green, sustainable pathway technologies. Next slide, please, Jen. Jen, can you, I don't have, there we go, thank you. A little bit about me. The details of this particular slide aren't important. If I describe myself to a public audience sometime, I describe myself as an overeducated blacksmith. I'm the person that works where a material and a process come together. And my career has included lots of adventures and across the world. Some of those are shown on the left. But really, those adventures have all been linked to the U.S. metal casting industry that I've worked closely with over my 40-year career. And we've done many collaborative, industry-driven applied research projects. I don't work in the exotic materials. I work in the blue-collar materials, the tonnage materials, irons and steels and aluminum alloys. Making processes better, improving the properties of materials. When I work with these customers in this applied research adventure, they want the answers yesterday. We're not doing things that can be applied 10 years out there. They want straight talk, not hype. You hear a lot of hype from university academic communities on new adventures, new exciting research, and how it's going to change the world. We change the world in small ways, but they want to hear it straight. And you have to speak industry's language. We try to do that as well. I'll try to cut out the jargon this morning as we talk and talk about things in a way that you can put them in place. So you need a cocktail napkin or a piece of paper. You need 2 or 3 takeaways that you can write down based on this talk. If you've done that, if you have some takeaways from this talk, I've been successful. Next slide, please. Because I'm going to be talking a lot about the metal casting industry or the foundry industry, I want to say a little bit about this industry. Because in reality, it's a lot like your industry, even though you might not be melting metal and casting metal. Here's a graphic that shows the metal casting industry in its basic sense. On the left-hand side, they take scrap metal. It's a low-value product. They take that metal and they remelt it. And when they remelt it, they produce useful engineering products with complex geometries, like the die-cast engine block that you see on the upper right-hand side. But as you know, they also use a tremendous amount of energy to do that. Things go up the smokestack, so they cause air pollution, they cause global warming, and of course, they have solid wastes. There are engineering solutions to all of these. We cannot just make engineered castings. We have to engineer all of our waste streams as well in industry. The center picture shows a energy snapshot of aluminum high pressure die casting, one segment of the metal casting industry. And if you look at energy usage, you'll see that over half of the energy that they use in the high pressure die casting business is for melting. They take molten metal, they hold it. And that uses a lot of energy as well. And if you look at non-processing energy use, it's only 9 to 10% for this particular segment of the industry. I put this graphic up here because that's very important to know where we should focus our energy savings activities on. And it's very clear that if you're an aluminum die casting organization, you have to look at your process itself. You have to look at the melting and holding of metal if you want to make an impact on that energy picture as well. And you have to look at what goes out the smokestack and what goes into solid waste out to the landfill as well. You'll see a description there of tacit and non-tacit energy when it comes to melting. If you're in the business of melting metal, you're going to use energy. You have to use energy. There's a theoretical minimum of tacit energy that you have to use to convert 100 tons of scrap per year into 80 tons of castings. But there's a lot of fluff, non-tacit energy as well that can be the focus of energy savings activities. Let's move on to one more slide, Jen, for the metal casting industry and talk about that metal casting world just for a moment, because I want you to be able to relate it to your world. Certainly, metal casting organizations, foundries melt metals and alloys, and they pour them directly into shape molds to make complex shapes directly, as in the upper right-hand corner, such as this particular valve casting. So they're making these complex shapes directly in shape molds, and they take steel that's $1.50 a pound, and they sell that as an $8 a pound casting. So there's a lot of value added here in these complex components that are highly engineered. Metal casting organizations are capital intensive organizations, but they're all, for the most part, small and medium enterprises. They have niche expertise, niche capabilities. They'll melt one type of metal, whether it's iron or aluminum or steel or brass and bronze. They'll focus on making small castings or large castings or maybe huge castings, but each organization doesn't cover that whole range. There are high volume production casting organizations with lots of automation, robotics, and efficiencies there. And there are also low production volume organizations that have more manual types of operations. Like you, they're all struggling to hire and retain employees as well. But certainly, all of you have unique challenges associated with your sectors in manufacturing. But in all of these small and medium organizations, probably just like yours, process change is difficult to manage. And many of the solutions that we're talking about when we're trying to make things greener, more sustainable, will require process changes. And we're going to talk about that using some case studies in the metal casting industry. And I think they apply to your organization as well. Next slide. So I want to take some topics off the table for today's discussion. We are not going to talk about technologies and solutions that have long payback periods. That's not a pathway for an organization. Yes, I can put in Andersen 3-pane windows in my house, and they'll reduce the heat loss through my windows. But if you look at that payback period of replacing existing good windows with newer, more energy efficient windows, that's a 40 or 50-year payback period in terms of energy savings, paying for that new product. That's not a pathway. And there are many times that people try to push things like that on our industries that don't have a pathway. We're going to talk about creating that economically viable pathway that makes us profitable, not with the final solution, but along the pathway. That's why I call it a green pathway solution. We're not going to focus on the little things. Yes, we can focus on using high efficiency lighting. Yes, we can focus on reducing air leaks so that our compressed air costs go down. We need to focus on the important things related to our process, the big energy uses, the big pollution sources. So I don't want to talk about the little things. I'm going to give you some case studies on the right pathways. But, those little things are important too. And I'll talk about that out of the other side of my mouth a little bit later as well. Next slide. This slide, like other slides, is going to have a lot of sometimes detail that I'm not going to talk about all the details, but the images are made just to present general pictures. But the headings are important. When we're talking about green pathway journeys, it's often some push from a regulation change or customer pull that are drivers for this change. We're happy to sit just where we are right now, making some money, producing product, shipping it out the door. But often these outside sources drive us to do things differently. And intentionally, most of these pathways that we take should also have cost savings and quality improvements along the way. And those become the driving force for all of the green solutions. It's the cost savings and the quality improvement. On the left-hand side, you see a widely used chart that shows number of major environmental laws and regulations over a period of time. And as you all know, they expand, they continue, and we continue to have to address and deal with regulatory push for changes to our processes. On the right-hand side, we also have customers pulling us in directions. This is an example of a pathway from a metal casting that is relatively crude in shape to a casting solution that's lighter in weight, more complex, and customers may be asking us to produce those products on the lower right rather than on the upper left. These drive change as well too. Next slide, please. And there are other drivers that are popping onto the screen. Many of you that are tier 1, tier 2 suppliers to organizations, whether it's the Caterpillars of the world, the John Deeres of the world, know that supplier qualification becomes critically important. We have to prove and show that we can be a quality supplier for components. In this case, the pictures are for castings. But we also have seen that now those tier 1 drivers, our customers, are asking all of us that are tier 2 and tier 3 to become sustainable. And sustainable is becoming actually a part of supplier qualification audits. So here's another push that we're going to have to continue to be aware of that's driving us to find sustainable green solutions as part of our processes as well. What I'd like to do now is leave this general discussion and move to some case studies. But before I do that, I just want to put one more slide up, Jen, because all of these green solutions, green pathways, are embedded into our technology. And we have to remember that that marketplace is pushing us toward necessary processes changes, and it's often quite subtle. I'm using an example here, and it's a chart that probably doesn't apply to you, but if you're an investment caster making complex shapes for the aerospace industry, you've been in this geometrical complexity world, and you've owned that whole space shown there in all three colors right there. But if you really look and get your crystal ball out there, you'll find out that, for example, there's a blue bar at the top for 3D metal printing. And new technologies can also invade and push traditional technologies and make you less economically viable as well. And you see a hybrid region. So industry is always on that cutting edge of technology, as well as on that subtle squeeze of sustainability at the same time. They're all interwoven together. So let's move to our main topic, green pathway technology. Next slide, please. Here's my definition of a green pathway technology. I don't know if this is commonly used throughout the industry, but a green pathway technology is a technology that can take my organization where I am right now with my current processes, my current emissions and waste, and move me all the way to a greener solution. And it's not just that greener solution that has to be a good solution. The entire pathway must be approachable and have an economic pathway as well. I can use an example of the Andersen windows. Yes, Andersen windows installed in my home will give me a much better, more affordable home to heat and cool summer and winter. But that investment in swapping out new improved windows and replacing my current technology is not a viable pathway. So we're talking about technologies that have a pathway. And that pathway starts with understanding a need, developing a technology, and it has to fit. So you have to develop it. You have to adapt it to fit your organization, your particular processes, your plant. And finally, it's as if you've adopted it. You don't even know it's new technology. It's part of your general way of doing business. But finding that target and finding that system solution that meets all of those criteria can be a mind-blowing pathway. And it's a solution that's a system solution that is impacted by your customer and the customer system. It's influenced by your workforce, putting in complexity that the workforce cannot adapt to and adopt is an unproductive system. Production systems, as your production requirements change, these systems have to change as well. And certainly a management solution, regulatory system. Be nice to talk in more detail, but let's move forward. We have a lot to cover here. I found that green pathway solutions are often met with a lot of initial skepticism. We've never done it that way before. This thing is not going to fly. And it's always an internal solution problem to find ways to get past that initial skepticism of doing things a new way. Next slide. And again, I mentioned before the easy, simple green stuff along the way. That's not the important stuff to do. However, You have to quiet the skeptics along the way. That efficient lighting, reducing compressed air leaks, production scheduling changes to reduce energy use, etc. Make sure you're also doing those things, but don't take your eye off the ball on the important process changes. And these are what I'm going to talk about. You can skip ahead 2 slides, Jim. I'm going to talk about 4 case studies. 3 of them are going to be from the metal casting industry. This first one is just a 1-slide general snapshot. Talks about work we've been doing with the oil and gas industry. Large company, happens to be NOV, National Oilwell Varco. They have the same battle. They have the same journey to develop and deploy tools that not only support their manufacturing and their product life cycle systems for oil and gas components, they also are along this green pathway. And that journey that they've taken as a large company is accessible to you as well, too. I have a picture here of my former student, Camilla Pisano. She started out as a university student working on an industry project. She developed and went along with them on a complex pathway to understand the need, develop a solution, adapt that solution, and adopt it. And in fact, they adopted her. She's now an NOV employee as well, too. So people are part of this as well, too. So don't forget the people part, even though I'm not going to focus on the people part. The graphic on the right just shows what that portfolio of green pathway technology looks like in this large organization for some products and processes we've been involved with. You see some tools on the side, you see some colors, and those designations there on the top are different plants. They have different facilities, and they can do a solution in one and adopt it and adapt it for another. And you see an entire portfolio here of projects. And in fact, even as a small and medium manufacturer, that portfolio of green pathway technologies becomes important to manage and to continually lead you along this way. Next slide, please. Okay, let's talk about a case study. And this case study applies to a metal casting plant. It's also used by heat treaters, and it's to demonstrate a green pathway technology for cost savings and energy savings. The motivation was energy savings. The reality were cost savings along the way. These have to be part of every solution. The picture in the upper right, I'm going to talk about a little bit and just talk about the charts in very little detail. But if you're heat treating some large steel castings in a car bottom furnace, and a car bottom furnace is 12 feet by 10 feet by 30 feet long, and it's heated up to a high temperature, you're heat treating castings at 2000 degrees Fahrenheit, perhaps. You see some glowing castings that have just been removed from a furnace there. The big question is, how long do I have to heat treat my parts? And you see a plot on the bottom that shows some complexity related to how long do I heat treat a part, because I put a cold part in a hot furnace. And you see a time plot there. If I put thermocouples in different sections of that particular furnace, and you can see it takes a long time to get up to 1700 degrees Fahrenheit, the heat treatment temperature. And the question is, when is my part up to temperature? So this became the green solution, allowing them to better understand when that casting reaches the appropriate temperature. And it's not an easy answer. You see, it's a complex answer. But the technology solution became important because it takes a lot of energy if you're heating for too long. And instead of an operator looking at it says, I think that casting is up to temperature, I think I can start the heat treatment clock, as opposed to getting a detailed specific answer on the left-hand side of this particular curve. I'm not going to talk about the details of the infrared signal that looks at the rate of change of temperature in a part by sending a look into the furnace. And I'm not going to talk about this complex chart, but what you see is at 3,600 seconds, a curve suddenly becomes flat. That's when that casting is up to temperature. And that allows me, because I can accurately determine that with some new technology, to not only save some energy, but save some time. Instead of heat treating for 5,400 seconds, I can now heat treat for 3,600 seconds. I've saved 30 seconds of time in a furnace. I can get more productivity out of that furnace and save energy as well. This is an example of a solution, a kind of case study. This is what you have to look at in your plant. Next slide, please. Here's a third out of 4 case studies that I want to talk about here this morning. And it, again, it has a lot of graphic details that I don't want to talk about in detail. The important things are the headings. This journey began back in 1995 with a foundry, and they were under severe pressure from the EPA to reduce VOC emissions, volatile organic compounds. And they embarked on a journey along with Penn State University in this particular case to develop an advanced oxidation systems, or an AO system. I'm not going to talk about the details of an AO system, but this is something that changed their process. The goal was to reduce emissions, and that's how we sold this project. And it never got off the ground until we realized there were also cost savings along the way. And in fact, we sputtered along reducing emissions, but not selling this solution that worked in one company, in companies 2, 3, 4, 5, and 10, and now it's in hundreds of companies, because we said we were going to reduce emissions. That left an image that they're going to have to spend money to reduce emissions, as opposed to, here is a system that will save you money. And by the way, it would also reduce emissions. I want to put 2 or 3 slides up to talk about aspects of this wide span technology. Next slide, please. This is a simple detail that tries to show the savings in a foundry. When foundries make metal castings, they make them in sand molds. They use that sand mold over and over and over again, and they have to keep adding new clay and new sand, new water to this to revitalize that sand so they can use it over and over again. But they also have waste in sand as well, too. So this shows a sand molding schematic here. And the only thing important are the numbers. And this is daily use of 9 tons of sand, 10 tons of clay and coal. And with the processing system, we were able to return a significant amount of that sand and coal and clay back and reuse it again, and reduce solid wastes, reduce an expensive ingredient that they had to buy and were throwing out. This is $1.5 million savings for a medium to large foundry operation, savings in coal and clay purchases. And at the same time, reduce VOC emissions. we found that the process changes here more than paid for any upfront systems costs. And it was only then that the adoption and adaptation of these systems for other foundries across the country and across the world were possible. Next slide. This 15-year pathway was allowing foundries to operate their process with annual savings and VOC reductions. It's actually, I'm not going to talk about the details again. It's going to change your process. It puts another control system in to control the addition of these advanced oxygens, to control the secondary recovery of materials. We began Fifth Wave with 15 years ago with first generation equipment that just reduced emissions. Next generation equipment allowed us to recycle these clays and coals and save a lot of money. And finally, now we're looking at systems that are even saving more money. Doesn't this seem like a no-brainer? Doesn't this seem like everybody across the entire world would adopt these systems? Well, actually, there are barriers to adoption and adaptation, because every time you save money, every time you reduce your purchases of products, you suddenly have a supplier that's supplying sand, supplying clay, supplying coal that is telling everyone this system is not going to work. It's going to cost you money, not save you money, because they're going to be selling you less sand, clay, and coal. So you have to be very careful who you listen to when you look at these new technologies. Next slide. I realize that was an esoteric example for many of you that aren't involved in making castings, but I wanted to talk about the systems that you have to put in place to make these things. Let's talk about one other case study here before I go. And a lot of times regulations suddenly apply. A number of years ago, the EPA again rediscovered that the sand that they use in the metal casting industry, when you process it, it creates dust. And this respirable silica dust is a hazard that you have to remove. They changed the definition of dust, and suddenly the exposure limits for dust changed dramatically, and the industry had to respond instantly. I'm not going to talk about those numbers right there, but the amount of dust that they're talking about here, if you took a Penn State's Beaver Stadium, a football stadium, and you put it in a box with a ceiling 100 foot high, that volume of air, and I've shown here a tablespoon of dust. That's what the new exposure limits for dust for employees became. And we have to deal with that. We don't make the regulations. We try to influence them in positive ways. But suddenly, that major ingredient we use to make sand mold, silica sand, it looked like we would have to replace that with other kinds of sand. Instead of using a sand that costs $80 a ton, now I'm going to have to bring in truckloads of non-silica sands that cost more than $350 a ton. You can see that suddenly there's no economically viable pathway. How do we solve that particular problem? The genie was out of the bottle. We had to find green pathway solutions to either replace all of that sand or engineered solutions to create less silica dust from that silica sand. Let's talk about that. Next slide. And boy, oh boy, on that pathway, there is a lot of regulatory testing that has to happen as well too. And the testing itself is just expensive. We're not talking about a solution yet. We're just trying to identify a problem in measuring air and respirable silica across a plant. On the left-hand side, you see the results of some measurements in the plant. Where is that dust? Where is it created? On the right-hand side, you see a worker with a where they're measuring that, identifying where that problem is, what specific operation that silica levels are high is important. Next slide. So let's focus now on green pathways to solve this, reduce the amount of silica dust that operators in the plant are being exposed to. I'm crossing two of them off the table, that they're not economically viable. Number one, I talked about using a sand that doesn't have respirable silica. $350 a ton versus $80 a ton. There's no pathway there to solve that. Or improve my dust collection. I can just blow a lot of air on all of my employees. I can blow that air out the stack and keep dust out of their lungs. But you find out that those dust collection systems as well are extremely costly. I have to heat all of that air in the winter. I have to cool all of that air in the summer. And just the energy to create that heating and cooling that I would need when I have a lot more airflow is also a global warming issue as well too. But here are three pathway technologies that are illustrated here. The sand that I typically use, $80 a ton, is a little bit angular. It's not perfectly round. However, I find out that if I can use rounder sand, it costs me a little bit more, $120 a ton instead of $80 a ton. Number one, I don't have sharp edges that are creating dust, and I reduce the respirable silica. And by the way, I can make better quality castings and less casting scrap that pay for that more costly sand. I have a pathway now where I can make castings cheaper and at the same time reduce silica respirable. And where do I make that dust? It actually turns out that it's the delivery of that sand into my plant that causes that silica grain to fracture and causes a lot of dust as well. So just going and paying attention to little things like transporting sand into my plant is important. And then there's a big solution, because I'm creating that when I'm mixing and mulling and creating my sand molds. I can save energy if I can shorten those cycles as well. And I want to just show three brief pictures. I know our time is short, and then we'll move on to questions. Next slide. The subtle benefits of using sand grains can be huge for many organizations. This shows a large 20-ton steel casting right here. And by using rounder sand grains, they save thousands and thousands and thousands of dollars of producing this product out the door because their finishing costs go down. Next slide. Pneumatic sand delivery, creating fines. Something you don't think about, but you have to work with other people. There's a system here. And when you're unloading that sand from the truck, the number of elbows that you take when you pneumatically transport that sand into your hopper, into your plant. It turns out that fixing those transportation problems can also reduce scrap in the casting. Looking at what fractures that sand, all of the fundamental areas, what creates that dust can have innumerable benefits. I'm not going to talk about the details here. And the next slide. This graph here is not important, but it turns out that many foundries are mixing their sand too long. If you mix your sand too long, you're grinding those sand grains on others, you're creating dust. And if you learn to mix sand better when you're making that sand and putting it, making molds, you can do it better. And it's amazing what we've learned on the mixing side of things. I'm not going to the details there, but we were mixing many batches of sand used to make molds for a long time. That wasted energy, that caused wear of equipment, that caused the silica dust. And we have learned by interrogating that mixing process to save money and also improve the quality of our castings. Next slide. So I've gone through 3 or 4 case studies, and I realize that they may not be specific to the industry that you're in, but hopefully the strategies that were used in these studies are important. Final piece of advice, talk to subject matter experts. You see some examples of who you may consider subject matter experts on the outside of this particular chart, but you really need to find the supermen and women that are subject matter experts. Just because Dave Lindell talks a lot about pillows doesn't necessarily mean he's a pillow expert. And some of you may think he is. That's great, and maybe he is. I don't know. If you have gray hair like me, you use books to find information. The younger generation uses Google. Google is not a subject matter expert in the level that you need to solve these problems. In fact, even that university professor is not that subject matter expert. It took me 5 years of working with industry experts, the guy in the upper right, the guy in the factory floor, and that expert metallurgist at that particular metal casting plant to learn how to solve these problems together. But finding those and putting together teams of the appropriate subject matter experts become important to solve those particular problems. Next slide. I've talked about lots of things, and I need to acknowledge a lot of the smart, talented, hardworking people that I work with. I'm not going to go into the details here, but a lot of these projects are big, expansive, and involve a lot of people and a lot of talent that I'm very grateful to have worked with. Next slide. And this is just a word of wisdom from an old guy with gray hair. Sometimes the only difference between stumbling blocks and stepping stones is how you use them. That's my word of philosophy for the day. Next slide. And with that, thank you. I'm going to be happy to answer any questions that people have. I have chat open, and I think if you put a question and answer, you can ask me a question and I'll try to give you a live answer to it. Someone in past said chat's not working, but hopefully the QA thing is there. I'd like to thank you for listening, and I'm going to stick around as long as you have questions to answer or until Jen kicks me off. Thanks to PenTap also for the invitation to speak.
Okay, so we're going to open into question and answer. Thank you so much, Dr. Voigt. I did have one follow-up question. For those who may not know what it is, could you discuss what an AO system is? Just a quick little description.
Sure. An advanced oxidation system, AO stands for advanced oxidation. We're actually, instead of adding water to make these sand molds so we can mold, we're adding water that is doped with ozone and hydrogen peroxide. These two together are in the literature called peroxone, and these are powerful advanced oxidants. They oxidize. And so we have organic compounds that are hydrocarbons. And when we hit them with this special water, it breaks them down basically into CO2. So instead of emitting methane and all these hydrocarbon compounds, we can burn those hydrocarbons at room temperature with these advanced oxidants. And they're short-lived radicals, so we have to incorporate them with the sand. And it turns out that we're creating these hydrocarbon organic compounds, and we can disintegrate them in those molds before they go out the smokestack.
Thank you.
It's the same thing if you have mold in a basement and bad smells. Buy a little ozone generator, and that ozone will take care of all those moldy organic compounds as well too.
That's good to know. I'm just checking. Does anybody have any questions? You can put it in the Q&A too. I think we did rectify the chat issue, but either way.
And don't hesitate to send me an email or a phone call. Happy if you have some specific questions as well too, and you don't want to ask it in front of this whole audience.
We'll give it about 1 more minute. And while we're waiting, so I had met Dr. Voigt. He actually came to a client of mine and offered them a lot of assistance. I think you had been there, 15 years prior, and then came back with me last year. And I just found some of his insights so invaluable. Like, if you do what we do as technical advisors, and I've said this before, sometimes we look at this big, broad picture and we forget the simple little things. And I learned a lot just being there with him that I never would have thought of. So he's been invaluable to at least one of my clients that I know of, probably several more. Or actually, you've worked with 2 of my clients, haven't you?
Oh yes, I've worked
Yeah,
with
yeah. And so with
a lot of the
yeah.
Pennsylvania foundry industry over the years.
So he's worked with quite a few of them and has been assistance.
And I would encourage all of you, life's busy. Hire that Penn State summer intern. Let them tear into some of these challenges. You often don't have time to try to tackle some of these bigger issues, but there's nothing like having a couple of Penn State interns there and turn them loose on some of these challenging projects that you're trying to find some answers to or collect some data. We can help you find those interns as well too.
I agree. And I mean, if you are having problems navigating, reach out to me, reach out to him. We can put you in touch with the proper people to get you directly to the College of Engineering. These kids are brilliant. It's the fresh minds. I know we use graduate assistants here at PennTap, and there are times where I learn a lot from them as well. And I think Dr. Voigt would back me on that. They're fresh, they're young, they have the latest knowledge, and they're ready to use it. So reach out to either one of us and we can get you connected if you are looking for interns. And keep in mind that fall is the time that you should be looking for interns. A lot of the good ones are taken by the end of the semester. So
absolutely. Ben asked a question. Some of you may not have the Q&A open. He says, do you see compressed air optimization being incorporated into energy cost savings? Any insight there? For many industrial organizations, the cost of compressed airs and running compressors is a huge cost, big cost. And looking at that from all angles is important. And certainly energy management. If you're not managing your energy, you're paying too much for your energy. And you have many of the energy providers that provide just tremendous assistance, and the people like Jen at PennTap work with you as well. But you're getting peak demand charges, and being able to manage that so that you can keep your electrical costs under control is critically important. Not just if you're melting metal, even if your energy costs are compressed air and other processing energy needs. Managing that energy is low-hanging fruit, and the picture keeps changing as the energy demand models that your utility use, and there are charlatans out there, and there are really good folks out there that can help you do that. So you have to choose correctly out there, but energy management is critical for everyone.
So building on his answer too, the energy management systems, that is what 50001 Ready is. So there's two versions. There is the ISO 50001 certification, which if you do any sort of contracts with the federal government, if you're doing them with European organizations, they are starting to request this more and more. We hear it for defense contracts and automotive the most. Aerospace is starting to be another one. Again, we do host a cohort. We have one going now. We may have another one next year. It is funded through the Department of Energy. But keep in mind, you can go through the Department of Energy's 50001 Ready website, and they actually have, you can do it on your own. They have a navigator there. They have, that'll walk you through every step of that playbook. It's about 26 tasks. And, we are here to answer questions for you as well. But it is, I know our clients have reported about 12 to 15% reduction in energy and just taking those first steps. So that program walks you through everything from putting together an energy management team to identifying your significant energy users to how you're going to manage those. And it can be everything from we're going to implement, there's a system called Scales for compressors, and there's a large foundry here in Pennsylvania that has that system. They have at least in the high 20 number of compressors, if not more, and they can use that system to tell you exactly how much compressed air is occurring at every step of their process. It's the only place I've worked with that has a system like that. It automatically rotates their compressors to prolong the life. And you can actually look at a step in your process and go, whoa, we're starting to use more compressed air here, but production hasn't increased. How do I find what's going on at that system? It can be a new operator, blowing off those molds and doing it way more than he needs to a compressed air leak, to malfunctioning equipment. So I just wanted to kind of build on that answer and throw that out there for you.
And if you fix leaks, you can reduce the system pressure sometimes and be successful and save lots of money.
Yes. If you actually, we do find manufacturers that they have their lines pressurized to, let's say 100 PSI, and the largest piece of equipment requires 90 PSI. So that is a very good point, and you will save energy that way. Ben has another question, and I think this is going to be more for you.
Sure. Yeah, this is a California question on heat reclaim off the dust exhaust incinerators. Would this help with air regs and particulate emissions? Ben, I'm not sure I'm entirely focused on the right thing, but in California, because of environmental regulations, what goes out that stack has, in many cases, to reduce organic compounds, VOCs, you have to put incinerators on all the exhaust that goes out the plant. That's an example of something that it's not value added. You're not making that. It's a cost every time you have to incinerate that air that goes off the place. And there have been, so certainly the technologies to alternate technologies to incineration always have to be looked at when you can in that kind of setting. But these systems have to be monitored when they go down. You have to report them to the California DEP. And I mean, there are all sorts of huge costs associated with high temperature processing in California. Ben, maybe the best way is let's have a phone call sometime and we can talk about it. But heat reclamation, it's hard. It requires systems maintenance, and high temperature heat reclamation is easy, but I'm not sure there are good solutions that are cost effective in this area. But again, it's a regulatory push that you have to respond to, perhaps.
Do we have any other questions? We're about 5 minutes over. I'm willing, if he's willing, to take more questions should you have them. But you do, again, you have the option of emailing Dr. Voigt. You can email myself. You will receive a follow-up email when the recording's live. But feel free to ask more if you'd like to. Otherwise, I'm probably going to end the recording in about another minute or two.
Yeah, thanks, everybody. I'll hang around for the last minute if anybody has questions. Well, Jen, I'd like to thank you and your team as well for making this so easy on my end to participate, taking care of all the technological needs.
I'm going to thank Elizabeth for that. But I do really, really appreciate you taking time out of your day to assist us with this webinar. It's been fabulous. I learned a lot just listening to you. And I think I am probably going to be reaching out here and there with follow-up questions about some things as I meet with more metal clients. But if nobody has any more questions, we're going to go ahead and end the webinar. Again, you can email me, you can email Dr. Voigt with follow-up questions, but thank you so much for attending and joining us today. And again, be sure to check out the EPA's pollution prevention week website. There's a wealth of information there as well, and you can always follow up with one of us if you have questions about what you see there. So with that, I think we are going to end the webinar. Have a great day, and thanks again. Bye.
Bye, everyone.